Here's our second example of a substitution problem where we want to solve a simpler problem or an easier problem within the context of a more difficult or more challenging problem. As I look at this problem, I see the opportunity to do a factoring, but I don't want to work with all the absolute values. So my first step is to say let k equal, any letter you want there, absolute value of 4x minus 3. This allows me to write the problem, the equation, as 2k squared. You see I replaced the absolute value 4x minus 3 with k, plus 17k, move this 21 over as a plus 21, equaling 0. Now I can factor that. Now I neglected to say that not all of these may be easily factored. You could always go through the quadratic formula and find your solutions that way. I'm going to choose to do my factoring because I enjoy factoring. My AC is 2 times 21, which is 42. My middle term is 17. And so the idea is, can I break 42 down to get 17? I think about that for a minute. I can do that with 3 and 14. 3 times 14 is 42, and 3 plus 14 is 17. So as I go to factor here, I'm going to break this first term down into the two sets of parentheses, and I'm going to consider first with first. First with first, 2k squared can only be created by me taking 2k times k. And then the values that I have over here have to represent the outer, and inner products. So 2 times what produces 14? 7. 2 times 7 produces 14. That's outer. That forces the inner to have to produce this 3. 1 times what produces 3? Positive 3. Now as I look at these solutions, I go through here, I can do my inspection. What produces a 0 here if k is negative 7? And what produces a 0 here is when k is negative 3/2. Some of you are a little more astute than others. You may be looking at this, scratching your head going, uh-oh, we got a problem. And we do have a problem. Because as I go back here and I put my substitution back to work, I have to turn this back into an absolute value. I get a statement that says the absolute value of 4x minus 3 equals negative 3/2. And once again, the absolute value of 4x minus 3 equals negative 7. If you're still wondering what I'm talking about, is it possible to take an absolute value and get a negative result? Take an absolute value and get a negative result? No. See, sometimes you'll get a negative and a positive when you do your factoring. That positive result would lead to 2 more answers. The negative one's considered extraneous. Here's an example where both of the answers to the factored form were negative, meaning that neither one of these will produce viable choices. They're both going to be extraneous sets of answers. So there's no solution here, and there's no solution here, which means that the problem would yield the empty set. There is no answer to this problem, and that can happen. You know, it's all part of these problems. I'm trying to stretch you here. You're going to find all the different things that can happen when you're solving equations. So here was an empty set. And once again, I know I didn't do anything wrong. I went through here. I factored this. Well, first I did my substitution. Got it to something that could be factored. I factored it. I produced my answers that were both negative. As I come back and put my substitution back in here, so I was representing the original problem, the absolute value of 4x minus 3, I noticed that each of those produced no solution, which meant overall there was no solution to the problem.